everybody. Welcome back to the training of the Modicon M221. In this video, we're going to see how we can use the IOScanner feature in the EcoStruxure Machine Expert to control a ATV drive. So in this video, we're going to see only the introduction for the configuration, and in the next one, we're going to use the function block in order to move the drive. So let's go into the presentation. So the idea that what we're going to see now is how we can configure the PLC in order to connect to an Altivar Drive. We're going to use in this part of the presentation, this part of the training, the Multiserial Communication. We're going to see the parameters that we need to configure on the drive and the parameters on the PLC in order to establish the communication. Then, depending on the drive, there is some additional features or configuration that we need to configure. For example, where you want that the Modbus, that the reference of velocity goes for Modbus and the control goes for Modbus for the drive. But for that, I have another videos in the configuration for each drive. So let's continue with this. So as you can see here, I have already predefined these settings for the master and this setting for the slave. Now, the idea in the next video will be to use these function blocks in order to control the drive, but in this one we're gonna see how we can read information from the drive. So, what we need to do is to configure our PLC in the Modbus serial line to act as a Modbus serial IOScanner as we saw in the previous one. But what we need to do is to modify the configuration that we already have to match the one that we have on the drive, okay, or vice versa, match the PLC to the one to the drive or the drive to the PLC. And depending on the drive that we have, okay, the settings, if you are in SoMove or on the embedded display, can be different. So what we need to do is to change this to match the one on the PLC. As you can see here, we have the ATV12. It has this visualization on SoMove. The ATV320, it has this visualization, okay. These are the parameters. And if we go to the ATV 600 or 900 series, you can see they have different views for the same. Okay, so now if we want to add this into the configuration, okay, we need to select the Multiserial IOScanner, select RTU transmission, and then in here, in the previous video, we saw the others to add a generic, but in our case, we need to select a drive. So if we click on this, we're going to see the list of different drives that we have in order to easily communicate with them. Select the drive that you want and then add. Once you add the device, okay, we're going to see some additional configuration, but this is something that I want to show you. There are the ones here, you have all the complete list, and on green you can see the ones that are still valid, and this one in red are the ones that are discontinued. Okay, just to give you an idea. Okay, and if you click on the presentation, you go to the catalog. So once you already define the drive that you want to program, you can see that is added into the list, and in here you can modify the name of the device. You can see over here. And you can also modify the slave address. In our case, we want that the slave address has the address 1. Once you have this, okay, we still have this initial requests and channels. But now, in the initial request, we have some predefined configuration. This configuration is linked to the scanner input and output that we have on the drive in order to easily exchange the variables that we want. So the idea of this initialization of the values is that you have on the drive like a list of on an area of variables that you can read and write information, that you can easily exchange information, one position and after the other one. So what it does in the initialization is to configure those registers with information that we want. As you can see here, I want to read from this logical position, as you can see on the drive, no, as you can see on the drive over here. Okay, I want to read these two variables. Okay, as you can see, is this visualization. It's just a configuration of this scanner input. Okay, this initialization will depend on the drive that we're going to select, as I'm going to show you later. And you can see that I have two different areas. One for, let me just change the view. We have one for input and one for output. And you can see here the output is the information that is going to be writing from the PLC, okay, to the drive. As you can see, CMD is the command word and LFRD is the velocity that we have, that we want the drive goes, okay, in RPM. This one is all the status. So basically the initialization channel or initialization request allows the PLC to predefine this list of variables that he wants to read. That is what it does. Now, if we continue with this, probably going to change the view. Now much better. Now, if we go to the channels that we have over here, this one, if we click on there, here we have a predefinition of the variables that we want to read. Okay, is this position. Okay, these values that are going to be here are linked to these variables. Okay, it's just a pre-configuration of the information that we are going to receive in this scan from the input and output. Okay, simple as that. There is nothing else to configure on the PLC, only this. Now, one question that you can probably ask is, okay, I already have this already defined list over here. Can we add more information? Yes, we can. You can add, with the add button, you can add more information in case you want something extra, okay? You can add it over here to read additional information from the drive. So now, before the practice, uh, let's see some behaviors. So let's go to an empty application. So I have this application of the PLC. Now, if we go to serial line, we can see here that we can select the Multiserial IOScanner. I'm going to change this to this baud rate. Okay, and this one is the parity, everything perfect, apply. Once you apply this, you can see the Multiserial IOScanner, RTU, and here we have the list of devices that we want. In our case, we're going to use the ATV12, which is the one I have connected here next to me. Now, in order to add this into the scanner, we just need to add. And just to show you, I'm going to add different devices. Let's add the ATV220 and A340 and ATV 930. Okay, so you can see in the ATV12 we have this configuration. Okay, the one I showed you in the part of the presentation. It's just to set the IOScanner table of variables. If we go to ATV212, it doesn't have that configuration because the ATV212, if we go to SoMove, it doesn't have the, it's waiting to load it, it doesn't have this IOScanner table as the ATV12 has. So let me just go over here, ATV320 to 12 here. Just add another one, okay. This one is obsolete, so don't worry. It doesn't have the, in the communication part, it doesn't have the the IO scanner or the IO list, okay, in order to easily exchange information. So the access of this information is done via the channels directly. You can see it has defined all this directly. If we compare this with the ATV12, it's just read for different position for the IO scanner list that we have. Okay, so basically what you need to do in here, define the drive that you have, and that's it if you want to control it or read information, because the software make all the configuration for you, so you don't need to do anything extra. Just add the device to find the slave address, and that's it. Okay, and then we're going to see the function blocks that we can use. So we have this, and here the ATV 340, you can see the list of parameters, the channels, same as the other one, ATV 930, the same configuration. So the PLC basically send the initial configuration in order to read in the channel, and then we can work on this. Okay, so I'm going to delete all this stuff over here. So now we have the channels over here, and these variables that are defined, I'm going to say this, can be found as we saw previous in the previous videos. If we go to the network, we can go to the input and output IOScanner registers, and we can see the information that we are reading. Okay, so if I know wrong, let me just go back to the presentation and see what is this. Okay, okay, so the output part is the CMD and LFRD, so we can define this in our application. Let me just go back here. So we can define a name, CMD, LFRD, okay, and for the input, okay, we can apply, and this one will be the ETA, if I know wrong, ETA and RFRD, RFRD. If I know wrong, this one is the actual velocity, this one is the status word for the device. So here, what we can do, if we have the program, okay, apply, we can read this information as we saw in the past. We can use the symbol ETA and move it to a percentage NW10, for example, and read it, okay, and execute something. Now, what we can do, okay, is to download this into the controller, okay, and see what's going on. But what we're going to do is to add an additional channel here on the device, add, and I'm going to read the ATV, I believe is the ULN, the parameter, which is the main voltage. So let me see here, the communication list for the ATV12, ULN, main voltage, 3207. So I want to read for this, read this one, 3207, okay, ULN, set to 0, okay. If I know wrong, if I this right, we should be able to communicate with the device. So I have in another project here some information that we have that we can read from the device. Okay, not from the device, but for the IO scanner, which is the diagnostic. So we can use, depend on the serial line that we are using, we have this %S system variables that have some information that we can do. We can suspend the network from the IO scanner or restart it. And we also had the possibility to see if there is any information going on from the serial line. So I'm going to copy this and paste it on our program example. Okay, paste it. Okay, good. So we can read and see what's going on. So now what I'm going to do is to connect with the PLC, log in. Let me see. Okay, run PC download. Perfect. And something that I haven't shown you is that is the drive is connected via Modbus serial. So in order to check the parameters, we can go, if I know wrong, configuration full. Then we have the communication COM. Here we have the address is 1. Here we have the power rate. You can see over there, and the transmission 8111. Okay, so out. That is done. So let's run the controller. Okay. Now what we can do is to create an animation table to see if we are able to read this information. Let me just put this in the side. Okay. Let me see in the presentation if there is something missing at the moment before the start. So configure the M221 mobile IOScanner, done. Add the drive that you have and change this to match ID1. Drive ATV, drive underscore ATV, the name. I haven't done this part, but it's very easy to change the name. Check the change information in request. We already see this. And configure the port, already done. Now you have the possibility to configure the drive using the embedded display, or you can use some mode plus the DTN and the cable. Now, probably should show the other window. There we go. So what we need to do now is to create the animation table, something I was going to do now, and see if we read some information over here. And then try to give a name of the nav variables. I have done this part. And also try to run the drive, okay, using the command cmd from this value 6, 7, 11 is the data state that the drive has in order to make it run. There are no magic numbers. So let's go back to the application that we have. No, this one is not. This one is running right now. So as you can see, we are reading something from the device. So I'm going to read the IWN 100.0.0 for, and now we're going to read 2 for the QWN. Perfect, good. So imagine this now. So I'm going to make this big. So this is the ETA. So this is the command word. So I told you before, if we need to run this, we need to enter some number 6, 7, and 15. This one is the velocity, which is in RPM. So this one, I don't know, just put 1000 RPM. And this one, CMD 6. You can see now the the drive is ready. 7 and now 15. See the drive is moving. Okay. If you need to disable, just double check. If you need to disable the drive, if for example you don't have a motor connected to the drive, you can disable the OPL configuration, output phase loss, so you can test the drive, the communication without having an error. So basically what we have done right now is to configure the Modbus IOScanner for the PLC, then add one of the drive that you have on the complete list, as you can see here in the configuration. Okay, select the drive, the reference or of the drive that you have. Then if you want, you can check the initial requests and the channels, and in the channels you can add more information as I show you, but I haven't checked that with you. Let me see, percentage IQ, no, IW and 100.0.4. 3. No, it's not that one. My bad. I don't remember. Input register, this one. So 100. 100.1.0. It was that one. I don't remember. 100. 101.0. You can see this is the voltage for the drive. So we have the communication. We can add additional channel to the original configuration that we have. One thing that we cannot do is to modify the initial request that we have. For example, if we open this program, if we go to the configuration, we are not able to do that. Okay, you have this lock over here in the initial request, and if you want to modify the channel, you don't. This one, yes, you can, but on the initial request, you cannot change that information. So we are sticking here to use the RPM to send the command to the drive. That probably could be the advantage if you are used to work in Hertz, but you need to make a conversion in the middle in order to configure the Hertz and then in the PLC make the configuration, the adjustment to send the RPM to the drive. That would be the only additional step that you can do. Now, in order to stop this, to stop the drive, it's very simple. We can set the 6. You can see here that it's in ready now, and if I change the velocity here 7, 15 again, you can see it changed the velocity. If I want, I can change this. I can still change it while it's still connected. Okay, so this is like a way to test and easy add the IOScanner connected to the ATV. The next step that we're going to see in the next video is to how we can use the function blocks in order to these function blocks in order to make the communication and the program much easier for us. Instead of changing the state from 6 to 7 or 15 or using the IOS on the ATV, we can use the function blocks. So thank you very much for watching this video and I see you on the next one.